Welcome to Brainwaves and Breakthroughs.
Okay, welcome to a deep dive. Today, we're taking a serious look at something that's really changing things fast. Generative AI.
Yeah, it's everywhere now.
Exactly. And this isn't the AI that just crunches data. This is the tech that actually creates completely new things. You know, images, audio, video, text.
All of it. And our source material for this dive is a really detailed report. It's called Unveiling and Evolving Generative AI.
Right.
It basically maps out the whole journey of this technology from the very first ideas right up to the cutting edge stuff we're seeing announced literally right now.
So our mission today is pretty clear. We're going to unpack this report for you.
Yeah.
We want to really get a grip on the core ideas. You know, how does generative AI actually work? Trace that history, which is actually fascinating. Look at some uses that might genuinely surprise you, and then importantly, dig into some of the big questions it raises for all of us. Think of it as like your shortcut to understanding this field that's just moving at lightning speed.
And the report makes a really crucial distinction right away between analytical AI and this generative kind.
Yeah.
So traditional AI, it's mostly about analyzing existing data, finding patterns, making predictions based on that data.
Right.
Generative AI, though, it's all about producing something new. The report uses this phrase like a smart computer friend that can make things up on its own. It goes beyond just calculation.
That ability to make things up, that's the fundamental shift, isn't it? And we're already seeing it. I mean, transforming creative fields popping up in healthcare.
Oh, absolutely. And places you wouldn't even expect. It's not some far-off sci-fi thing anymore. It's here, it's integrated, it's changing how we make and consume content, and it's definitely making us rethink quite a lot.
Yeah, no kidding. And speaking of rethinking, we've got quite the journey mapped out based on this report.
Yeah.
We'll kick off with history, the roots, then get into the core concepts, the algorithms. We'll look closely at a big recent example, Google's VO3 video model.
That's a big one.
Definitely. Then we'll talk about what it actually takes to train these massive systems, explore those surprising applications we mentioned, and wrap up with the bigger picture considerations. Okay, let's get into it.
Okay, let's start right at the beginning. The foundational stuff really goes back to the mid-20th century with the formalization of computing. You know, Alan Turing's work.
The Turing test.
Exactly. The Turing test, can a machine seem indistinguishable from a human? That whole question.
The actual term artificial intelligence, that came later, the Dartmouth Conference.
That's it, 1956. And back then, AI was, mostly symbolic, rule-based systems. Think early chess programs, stuff like that.
Logic-based.
Right. But even then, the report points out these little sparks of creative potential, like Harold Cohen's Aaron project.
Aaron, yeah, I've heard of that. Started in the late 60s.
Yeah, and what's fascinating is Aaron wasn't just like tweaking existing images. It was designed to generate original drawings, black and white line drawings, from scratch.
From scratch, using rules Cohen programmed in about, physics and composition?
Pretty much,
Yeah.
Which is kind of mind-blowing for the tech available back then. The report also mentions others exploring digital art around then, like Jorg Nies, Frieder Nake.
Hey, Michael Knoll.
Right, those pioneers. So the creative impulse was there early on.
And on the language side.
You had Eliza, the chatbot from 61. Very simple, pattern matching really, but it simulated conversation. A first glimpse of natural language processing.
So generating art, simulating conversation. Very human things were targets from the get-go. Meanwhile, neural networks, the idea was there, but the first working multi-layered one, the cognitron, that wasn't until 75.
Correct. A big step towards deep learning, better pattern recognition. But then, the report reminds us about the first AI winter.
Yes. Things cooled off.
They did. Roughly 73 to 79. There was, hype over-promising.
Didn't deliver quite as fast.
Exactly. So skepticism grew, funding got cut, the classic cycle.
But the work didn't totally stop.
Right.
Right? Machine learning just went a bit more underground.
Kind of. It found niches, practical applications, maybe less flashy stuff like in automated phone systems. But the research continued.
And the 80s brought some progress.
Yeah, models like the Hotfield net. But a real pivotal moment the report highlights is 1986. Backpropagation.
Backpropagation. That's key for training neural nets.
Hugely important. Though it took Jan LeCun's work in '89, applying it to recognize handwritten ZIP codes for the post office.
Oh, wow.
That really showed its power for deep learning in a practical way. That kind of solidified deep learning as a viable path forward.
Okay, so that proved it could solve real problems. What else fueled the fire?
Hardware.
Yeah.
You absolutely cannot overstate the importance of hardware, specifically GPUs.
Graphics cards, basically.
Yeah, graphics processing
Yeah.
units. Late 90s, NVIDIA's GeForce 256 in '99 is a milestone the report mentions. They just blew the doors open for parallel processing speed.
Which is exactly what you need for training these huge networks.
Precisely. That computational power really enabled what the report calls the data-driven era. Suddenly, you could build much bigger, much more complex models and actually train them on vast amounts of data in a reasonable time.
More power, bigger models, more data, and specialized types of networks started emerging too.
Right. LSTM's long short-term memory networks from '97, super important for sequence data.
Like speech.
Or text. Exactly. Speech recognition, language translation, anything where the order matters over time. And we saw massive improvements elsewhere, like facial recognition. The report notes like a 10-fold accuracy jump between 2004 and 2006. They could even tell identical twins apart reliably.
Wow. Okay, so all these pieces, algorithms, hardware, data, were coming together.
Mm-hmm. Which sets the stage for the current boom, the generative AI explosion, really kicking off in the 2010s and just accelerating like crazy now. We got used to virtual assistants. Siri came out in 2011.
Chatbots everywhere.
Yeah, but the real leap in generative power came from some major architectural innovations, and the report singles out one absolute game changer: GANs.
GANs. Generative Adversarial Networks. 2014, Ian Goodfellow. Those were the ones that felt almost like magic when they first appeared, creating those incredibly realistic, fake faces and images.
They really were stunning.
How does that adversarial thing actually work?
The report uses this great analogy: a counterfeiter and police. You have two neural networks locked in this, like, competitive game.
Go.
One is the generator, the counterfeiter. Its job is to create fake data, say images that look totally real. The other is the discriminator, the police. Its job is to look at both real images and the generator's fakes and figure out which is which.
So they're constantly trying to fool each other. One gets better at faking, the other gets better at spotting fakes.
Exactly. The generator learns from the discriminator's mistakes, figuring out how to make its fakes more convincing. The discriminator gets better at noticing the tiny flaws. This constant battle pushes both of them to improve until, ideally, the generator's fakes are so good the discriminator's basically guessing, like 50-50.
And at that point, the generator's really good at creating realistic stuff.
Yep. That's the core idea. And GANs were revolutionary for making hyper-realistic images, video synthesis, even starting to explore text-to-image.
But they weren't perfect, right? The training could be tricky.
That's the downside the report mentions. Training could be unstable. Sometimes you'd get mode collapse, where the generator just keeps making the same kind of thing over and over, losing variety.
Ah, okay. Still, a massive leap.
Undeniably. But then, more recently, we've seen the rise of diffusion models.
Right, and these often seem to edge out GANs now in terms of, like, stability and maybe even the quality of the output.
In many cases, yes. Diffusion models use a totally different logic. No adversarial competition. Instead, they learn by reversing a process of adding noise.
Adding noise. How does that work?
Imagine you start with a clear picture. Then you gradually add random noise step by step until it's just complete static. The diffusion model learns how to undo that process. It learns how to take the static and step by step, remove the noise to get back to the original clear image.
Okay, so it learns denoising, essentially, like cleaning up a fuzzy TV signal. The report mentions sculpting from dust, too.
Exactly, or denoising a static TV picture. That step-by-step refinement process tends to be more stable to train, and it's proven really good at generating very diverse, high-fidelity outputs. It handles complex data really well.
And diffusion is the engine behind a lot of the big names now, Stable Diffusion, Google's Imagen.
Midjourney uses it too, I believe. And crucially for video, models like OpenAI's Sora and Google's VO3, which we'll get to.
What makes video generation so much harder than still images? It's just a sequence of images, right?
Well, yes and no. The challenge is temporal consistency. It's not enough for each frame to look good on its own. Things need to look right and move coherently across time.
Ah, so objects shouldn't just flicker in and out of existence or change shape randomly between frames?
Exactly. That requires specialized layers in the model, attention mechanisms that look across frames, not just within a frame. The report even mentions technical details like using temporally consistent noise in the diffusion process to help ensure that smoothness over time.
Fascinating. So we've got GANs and diffusion as ways to generate the pixels or sounds. But often, especially with text prompts, you need something to understand the meaning and context first. That's where transformers come in. 2017, that Google paper, Attention is All You Need.
That paper was a bombshell. Transformers completely changed the game, especially for natural language processing initially. Think GPT, BERT, they're built on transformers.
And the key was self-attention. What does that actually mean?
The report uses the analogy of a super attentive librarian. Imagine you're reading a sentence or even looking at parts of an image. Self-attention allows each part, each word, each pixel patch to weigh the importance of all the other parts in the sequence, no matter how far away they are.
So it can figure out that a pronoun way later in a sentence refers back to a noun at the beginning, or that this part of an image relates strongly to that other part.
Precisely. It captures long-range dependencies and context incredibly well. Technically, the data gets turned into numerical embeddings, goes through encoder and decoder layers that heavily use the self-attention mechanism to process and generate.
It sounds really powerful for understanding relationships within data.
Immensely powerful. And crucially, the architecture is highly scalable. You can build massive models with billions, now trillions of parameters, and it's versatile, works great for text, but also adapted for images, audio, video. It's fundamental to almost all modern large-scale generative AI.
Including multimodal AI, which seems to be the next big frontier handling text, images, audio, video altogether.
Definitely. Multimodal is about systems that can process, understand, and generate across different types of data simultaneously. The report likens it to a super translator library. It takes input from different modalities, maybe text and an image, and learns to represent them in a shared internal embedding space. This involves cross-modal alignment, basically teaching the AI how concepts connect across modalities. Like the word dog, the image of a dog, and the sound of barking all relate to the same core concept in this shared space.
So it builds a unified understanding. If you ask it to generate a video of a dog barking, it accesses that shared concept to create both the right visuals and the right sounds.
Exactly. That integrated understanding allows for much more nuanced, context-aware generation.
Wow. When you lay it out like that, Turing, Aaron, neural nets, backprop, GPUs driving things, then jams, diffusion, transformers leading to multimodal, you really see how it all builds.
It's a continuous chain of innovation building on previous breakthroughs. And that pattern the report mentioned, the AI winters followed by booms.
Yeah.
It shows how important sustained fundamental research is, even when the applications aren't immediately obvious. Sometimes the ideas just need the hardware or more data to catch up.
That's a great overview of the history and the main architectures. Now let's get a bit deeper into the concepts. You mentioned latent space. What exactly is that? It sounds kind of mysterious.
It does sound a bit abstract, but it's central. Think of it as the AI's internal idea space, or maybe its blueprint room.
Latent meaning hidden, right?
Yeah, exactly. It's a lower dimensional mathematical space. When the AI processes, say, an image, it compresses all those pixels down into a much smaller set of numbers, a point or a vector, in this latent space. These numbers are like a hidden, compressed code representing the essential features of the image.
So it's not storing the image itself, but a kind of numerical summary.
Precisely. It's an abstract representation. The axes in this latent space usually don't correspond directly to things we easily understand, like brightness or object size. They capture more complex, learned relationships.
Okay. The report used analogies like an idea map or recipe book.
Those are good ways to think about it. Or imagine plotting photos of faces on a graph based on just two numbers derived by the AI. Navigating around that graph, changing those two numbers slightly, would generate new, different faces.
Like the aging app example. You find the face in latent space, find the direction that corresponds to older, and move along that vector.
That's exactly the kind of manipulation it enables. Or, for text, similar words or concepts get mapped close together in the latent space. This allows the AI to do interesting things, like combining concepts numerically. The report had that wild example.
Oh, the sheep plus spider politician one.
Yeah, which perfectly illustrates that the AI isn't understanding in a human way. It's operating on statistical correlations it found in the data. Sheep and spider might share some latent numerical features that, when combined, happen to be close to the features associated with politician in its training data.
Okay, that really drives home the non-human nature of its thought process. It's all math and statistics.
Absolutely. And that's a crucial point the report makes about being careful not to anthropomorphize these systems too much. Their understanding is fundamentally different from ours.
So the process is encode real data into latent space, manipulate the numerical representation there, and then decode it back out into new data.
That's the core loop. And often, a key property is that this latent space is designed to be continuous and smooth. Meaning small changes in the numerical coordinates within the latent space lead to small, gradual changes in the output. If you move slightly in the age direction, the face gets slightly older, not suddenly jumps to a completely different person. This smoothness is vital for generating coherent sequences or transformations.
Makes sense. You need that smooth landscape to navigate.
Yes, although the report does note that discrete representations, like using word tokens, are also incredibly powerful, especially with transformers. But the core idea of an internal, learned representation space is key.
Okay, so if latent space is the AI's internal map of ideas, how do we tell it where on the map to go? That's conditioning, right?
Exactly. Conditioning is how you guide the generation process. You provide extra information, the condition, to steer the AI towards a specific kind of output.
Like giving directions on the map.
Perfect analogy.
Right.
Or the report uses the recipe idea. Instead of just asking the AI to generate a cake, which might result in anything, you condition it by providing a recipe. Chocolate cake with sprinkles and 3 layers.
So the text prompt, a cat wearing a hat, is conditioning the image generation.
Precisely. Or you could condition it with an input image, make this photo look like a Van Gogh painting, or even audio cues. It focuses the AI's creative potential within that vast latent space onto the specific thing you want.
Which makes the models way more useful and controllable.
Absolutely. It allows for targeted generation, aligning the output with desired features. To do this effectively, though, the AI needs to be trained on data that includes these conditions paired with the corresponding output, so it learns those relationships.
Got it. Latent space is the internal blueprint. Conditioning is the specific instruction. That really helps understand how models like text-to-video work. Which brings us neatly to Google's VO3.
Right, VO3, Google's big new video generation model unveiled just recently, May 2025. Its position as a tool for filmmakers, storytellers.
And just to be super clear, because the name is similar, this is not the VO sports camera that uses AI to follow the action.
Excellent point to reiterate. No, completely different things. VOCam 3 is hardware, a camera. VO3, the focus here, is the software model that generates video from prompts.
Okay, so how does this model work? What's the underlying tech?
It's built on that diffusion architecture we talked about.
The denoising process.
Exactly, refining noise into coherent frames, but crucially, doing it with that temporal consistency needed for smooth video.
And what's its main selling point, or its big breakthrough capability, according to the report?
The report really highlights its multimodal training. It didn't just learn from video frames, but also from associated audio and text descriptions. This deep understanding across modalities enables its standout feature. VO3 can generate video with accompanying audio sound effects, ambient sound, even dialogue natively.
Natively. So you give it one prompt and it creates both the visuals and the matching soundtrack simultaneously.
That's the idea. It's a pretty significant step towards creating a more complete piece of content directly from the AI, potentially simplifying workflows quite a bit. No need to generate video, then go find or create audio separately.
That sounds impressive. What about the quality? What can it do?
Google's aiming high. They talk about photorealistic visuals, resolution up to 4K, a real cinematic quality with fine detail. The report mentions it handles physics simulation reasonably well for natural movement, and it can do accurate lip syncing if generating dialogue, plus that native audio.
And how much control do you get as a user? Can you give it detailed instructions?
It seems quite capable of understanding complex prompts. The report calls it handling a story in prompt. And you have parameters. The main text prompt, obviously. You can optionally feed it an initial image to start from. There's a negative prompt to say what you don't want to see.
Well, like no cars or something.
Exactly. Setting the aspect ratio, like widescreen or vertical, controlling person generation, maybe you want to allow people, or specifically disallow them. You can ask for a number of videos to get options, and importantly, duration seconds.
How long can the videos be?
Well, the demos showed clips up to maybe 20 seconds, but the preview API seems limited to around 5 to 8 seconds currently, so still relatively short bursts.
Okay. Any other catches or limitations mentioned?
Well, aside from the length and the fact it's in limited beta, the usual caveats with generative models apply. Sometimes you might still get slightly uncanny-looking faces or small glitches and inconsistencies, but the quality seems generally very high from the examples shown.
And how does Google envision people using it? Is it just a standalone tool?
It's integrated into a broader platform Google calls Flow, which is described as an AI filmmaking tool. Flow provides more fine-grained control over characters, scenes, visual styles, aiming to really speed up workflows for creators, marketers, corporate training videos, that sort of thing.
Interesting. How does it compare to the other big-name AI video, OpenAI's Sora? The report drew a comparison, right?
It did. They seem to have slightly different strength and maybe target audiences, at least initially. VO3 is pushing hard on fidelity, sharpness, that 4K cinematic look, prompt accuracy, good physics, and especially the native audio. It feels positioned for professional creative and marketing use, which is also reflected in the pricing the report notes. It requires a high-tier Gemini subscription, around $250 a month.
Okay, so positioned as a premier professional tool. And Sora?
Sora impressed everyone with its ability to generate longer clips up to 60 seconds, and its really dynamic scenes with complex motion and physics. However, it's generally seen as lower resolution than VO3's 4K output, and perhaps more geared towards developers and researchers at this stage. Early Sora examples sometimes had issues with, like, objects behaving weirdly over time, or slightly distorted people or animals in complex movements.
So maybe VO3, aiming for high fidelity, shorter, more controlled outputs for professional use cases, while Sora explored longer, more dynamic generation, perhaps with a few more rough edges initially.
That seems like a fair summary based on the report, and it raises that interesting point about access.
Yeah, the AI divide.
Potentially. While the tech could democratize creation, these cutting-edge, highly capable models are often being launched with expensive subscription tiers or aimed at professionals. It feeds into that whole debate. Is AI here to replace creative jobs or augment them? And who gets access to the best augmentation tools?
It's a really important question. Okay, so we see what these models can do.
Yeah.
Let's talk about the massive effort behind the scenes. Training these things sounds like a Herculean task.
Oh, it absolutely is. The report paints a picture of a highly complex, multi-stage pipeline. It's not like just compiling code. It's more akin to setting up a massive industrial assembly line or maybe preparing an incredibly elaborate gourmet meal, but at scale.
Okay, break down that pipeline for us. Where does it start?
Stage 1 is data collection and preparation, gathering the ingredients. First, you define your goal. What should the AI learn to generate? Then you need data. Vast amounts of diverse, high-quality data relevant to that goal.
Images, text, video, code.
Whatever's needed. And it could be human-created content or sometimes even synthetically generated data to fill gaps. But just having the data isn't enough. It needs intense pre-processing.
Cleaning it up.
Cleaning, removing errors, standardizing formats like tokenizing text, creating audio spectrograms, and crucially, labeling, adding descriptive tags, metadata, captions. This is incredibly labor-intensive but vital for the AI to learn meaningful connections. Like a chef meticulously prepping ingredients, the data has to be clean, relevant, and well-organized.
Garbage in, garbage out, as they say. Okay, ingredients prepped. What's next?
Model selection and training, the cooking stage. You choose the right architecture, GAN, diffusion, transformer, maybe a mix based on the task and your resources. You implement it, writing the code to define the network, layers, connections, everything. Then the actual training begins.
Feeding the data in.
Repeatedly. You feed the prepared data through the model over and over, potentially for days, weeks, or even months. The model makes predictions, compares them to the actual data, calculates errors, and adjusts its internal parameters, millions or billions of them, using algorithms like backpropagation to gradually get better. This is where the AI learns the patterns, the style, the knowledge embedded in the data. It's like the slow cooking process where the flavors develop.
And once it's cooked, you have to check if it tastes right.
Exactly. Evaluation and refinement. The tasting and perfecting, you test the trained model rigorously, use quantitative metrics, but also often human evaluation to see how well its outputs match the goals. Does it generate plausible images? Is the text coherent? You look for problems like overfitting.
Overfitting. Meaning you just memorize the training examples.
Yeah, instead of learning the general patterns. If it overfits, it won't generalize well to creating new unseen things. And this stage isn't just testing. It's part of a continuous feedback loop. User feedback, corrections, ratings, this all gets fed back in to further fine-tune the model and improve its performance over time. It's like adjusting the recipe based on taste tests.
So it's an ongoing refinement process. Are there other components in modern pipelines?
Yes, the report mentions a couple of important additions. Often, data is converted into those numerical embeddings we discussed and stored in specialized vector databases. These allow for incredibly fast searching and retrieval of relevant information during generation. And that connects to another key piece: retrieval augmented generation, or RAG.
RAG. What's that?
Think of ARTI as giving the AI an open book exam. While it's generating an answer or text, it can quickly pull relevant snippets of information from a vast external knowledge base, often stored in those vector databases, and incorporate them into its output.
So it can ground its answers in specific retrieved facts, making it less likely to just make stuff up.
Exactly. It makes models, especially language models, much more factual and reliable for information-based tasks.
And pulling all this off the data, the training, the refinement requires truly staggering amounts of resources.
The scale is immense. The report uses terms like massive amounts of training data, immense computational power. We're talking petabytes of data. Training requires specialized hardware for thousands of GPUs or other AI accelerators like TPUs or IPUs linked together in huge clusters.
Why clusters? Why not one giant computer?
Because no single computer is powerful enough. Training these models involves distributing the calculations across potentially thousands of machines working in parallel. It's the only way to get the training done in weeks or months instead of years or decades.
And that costs a fortune, presumably.
Both in terms of the hardware itself and the sheer amount of electricity needed to run and cool these clusters. The report highlights the escalating costs and energy needed. Even tiny inefficiencies in the process get magnified at this scale, adding days to training time and significant cost.
Which reinforces that point about who can afford to build these foundational models.
It really does. It concentrates a lot of power with the big tech companies and well-funded research labs that have access to these resources. It raises serious questions about that potential AI divide and also about the environmental sustainability of training ever larger models.
And it's not like you just train it once and you're done, right?
Yeah, not at all. The report stresses these AI pipelines are products, not one-off projects. They need constant maintenance, updates, retraining on new data, continuous evaluation, that ongoing feedback loop. They're like living systems that need tending, which is a huge operational challenge in itself.
Okay, so a monumental feat of engineering and resources lies behind these seemingly effortless creative outputs. Let's shift focus now to those outputs and some of the surprising ways generative AI is being used, beyond the usual suspects.
Right. While text-to-image tools like DLE or Midjourney and now video tools get a lot of buzz, the applications are spreading incredibly wide. The report highlights AI as a co-creator across many fields. We mentioned art, building on Aaron's legacy.
And music.
Definitely. From early experiments to modern AI like Google's Magenta or OpenAI's MuseNet that can compose entire pieces, but also increasingly tools that act as co-producers, generating maybe a drum track, a bass line, or chord progressions that a human musician can then weave into their work.
Makes sense. And filmmaking, with VO3 and Flow, is clearly a major area.
A huge area of development right now, yes. Generating clips, visuals, even dialogue and sound design from prompts.
But the report listed some really unexpected uses. That's where it gets fascinating.
It really does showcase the versatility, like beekeeping.
Beekeeping.
Seriously.
Yeah. Analyzing data from sensors in hives, temperature, humidity, bee movement, sounds to monitor the colony's health, detect problems early, maybe even optimize pollination schedules.
Wow. Okay, what else?
Historical fiction writing. AI analyzing vast amounts of historical texts, maps, maybe even, as the report mentions, genetic data related to populations to help generate more plausible dialogue, social settings, or character backgrounds for a specific time period.
Using AI to check historical plausibility.
That's wild.
Isn't it? Then there's medicine. Enhancing medical scans, MRIs, CT, X-rays, helping radiologists spot anomalies like tumors, potentially making diagnostics faster and more accurate, and that incredible application in speech synthesis for ALS patients.
Creating a synthesized voice based on their own earlier recordings.
Exactly, allowing them to communicate in a voice that still sounds like them. That's profoundly impactful.
Truly. What other surprising areas did the report mention?
Preserving traditional crafts. AI can be used to digitally document intricate designs or processes, maybe even train robots to replicate certain artisanal techniques, helping to keep endangered crafts alive.
That's an interesting blend of high-tech and tradition.
It is. Also, the food industry, AI exploring novel flavor pairings by analyzing chemical compounds and ingredients or predicting food trends. Environmental monitoring, analyzing satellite images, drone footage, sensor data to track wildlife, identify illegal logging or poaching hotspots, model ecosystem changes for conservation.
Using AI as a tool for conservation.
Yeah. Agriculture, too, identifying crop diseases or nutrient deficiencies early from aerial imagery, helping farmers improve yields and use resources more efficiently. And even customer service things like AI voice changers for call center agents or more sophisticated virtual assistants providing support.
The sheer breadth is staggering. It really paints a picture less of AI replacing people across the board and more of this intricate human-AI partnership emerging.
That's definitely a key theme in the report. In many cases, the AI takes over the tedious, time-consuming parts, transcribing interviews, removing background noise from audio, generating initial drafts or variations. This frees up the human creator to focus on the higher-level strategy, the unique insights, the final polish.
So it becomes a tool, a powerful assistant.
Many professionals are starting to see it that way, yeah.
Mm-hmm.
A powerful ally, as the report puts it, helping them produce more, maybe better, content, exploring ideas they couldn't before.
Oh.
It can personalize content, create multilingual versions quickly.
But as it gets integrated like this, it must challenge old ideas.
For sure. Traditional notions of authorship, creativity, who gets the credit when AI is heavily involved? The report says it's breaking old ideas about who is the artist and who is just helping.
Which leads directly into the challenges and the darker side of this technology. Because with all this power
comes significant risk. The report is clear about this. One major concern is deepfakes and misinformation.
Right, creating fake videos or audio of real people saying or doing things they never did.
Exactly. The hyperrealism makes it incredibly easy to deceive. We've already seen AI images go viral that fooled millions. As the tools get easier to use, the potential for spreading disinformation, manipulating opinions, or eroding trust in media just grows.
And the models themselves aren't flawless, are they? They still make weird mistakes.
Oh, definitely. The report mentions they can still struggle with details, generating hands with too many fingers, weird textures, faces that fall into the uncanny valley, and crucially, they can inherit and even amplify biases present in their training data.
Reflecting societal biases back at us, or even making them worse.
It's a serious problem that requires careful auditing and mitigation strategies during development and deployment.
And the impact on jobs remains a huge question mark.
Essential one. Understandable anxiety exists, especially in creative fields. Will actors, voice artists, illustrators, writers be replaced? The report presents both sides. The replacement fear versus the view of AI as an augmentation tool, like power tools in carpentry, making the carpenter more efficient, not obsolete.
But the outcome is still uncertain.
Very much so. It's playing out in real time.
And the ethical and legal questions around authorship, copyright for AI content.
Totally unresolved territory. If an AI generates an image based on your prompt, who owns it? You. The AI company. Nobody. What about using AI to mimic a specific artist's style or a singer's voice? Companies like Google are adding things like synthide watermarks to VO3 outputs to identify them as AI-made.
But the broader legal frameworks are lagging way behind the tech.
Far behind. We're just starting to grapple with the implications for synthetic performances, digital likenesses, creative ownership.
It really feels like the core tension is that the very realism making AI so powerful for creativity is exactly what makes it so potent for deception.
That's the double-edged sword, absolutely.
Sure.
The report touches on this philosophical level, too. It points out that AI often feels convincing because it's good at mimicking the signals that trigger our "that's a person" or "that's real" responses. It leverages our tendency to anthropomorphize.
It hacks our perception, in a way.
You could say that, and this forces us to ask deeper questions. What does human creativity really mean if an AI can generate art or music that evokes emotion? What is intelligence? What is consciousness? When AI gets so good at mimicking the outputs, we have to reconsider the processes.
So it's not just changing the tools we use, it's potentially changing how we see ourselves.
Precisely. The report suggests it pushes us to value the uniquely human dimensions, maybe deep emotional understanding, lived experience, ethical judgment, true abstract reasoning, the things AI still struggles profoundly with. It's sparking a massive conversation about the human condition in the age of intelligent machines.
Wow. Okay, this has been an incredibly rich deep dive. We've covered a huge amount of ground, from those earliest AI concepts and creative sparks.
Through the key algorithmic breakthroughs, neural nets, backprop, GANs, diffusion, transformers.
Driven by hardware advances like GPUs.
culminating in these powerful multimodal models like VO3 that can generate remarkably realistic video, now even with native audio.
We've seen the complex, resource-heavy pipeline required to train them.
And explored that surprisingly wide range of applications far beyond just chatbots and image generators, touching everything from beekeeping to medicine to preserving crafts.
And we've wrestled with that inherent duality, the immense creative potential versus the serious risks of misuse, bias, deepfakes, and the unresolved ethical and societal questions.
Yeah, the report makes it clear. This technology is powerful, transformative, and complicated. The line between what's digitally generated and what's real is undeniably blurring.
Which really leaves us, and you listening, with some big things to ponder. Here's one thought to take away. As generative AI gets better and better at creating things that look, sound, and maybe even feel real, what does that mean for human creativity? What becomes uniquely valuable about what we create?
Or perhaps, how do we learn to navigate a world where telling the difference between authentic human expression and sophisticated AI generation becomes increasingly difficult yet increasingly vital? It's a conversation we're all going to be having for a long time.
It really is just beginning. Your curiosity is definitely the key to navigating what comes next. Thank you for joining us on this deep dive.